you crazy fool, you've gone ahead and done it. They did it. It's up there. It's moving out to its Lagrange point. It's unfurled the sun shield, tensioned the sun shield. It's quite amazing. It's an absolute miracle. And now that it's heading out there, what's it going to do for us, Terry? What are the amazing things this telescope is going to do?
Well, a lot of people wonder why it's going to operate mainly in the infrared. We all like the lovely pictures from the Hubble Space Telescope and the other Earth-based telescopes and so on. We will get some from the James Webb, but not quite the same sort of thing. The reason it's going to operate mainly in the infrared is that it wants to look back as far as possible towards the very birth of the universe, the Big Bang, and what happened immediately afterwards. And there are a number of issues there, but the main one is that is so far away, and the light, all the radiation, in fact, because of the expansion of the universe, has been stretched, what we call redshift. And most of the light that is coming to us from the events in the very early universe has been stretched from the visible well into the infrared. So to look at the galaxies and the first stars as they were about 13.5 billion years ago, you need to be able to see into the infrared. So it will be looking at the birth of the first galaxies, the birth of the first stars. Even closer to home in our own galaxy, there's an awful lot of stuff in our galaxy that we can't see properly because it's obscured by dust. And infrared light penetrates through dust. So you can see the very early stages of planetary formation of the protosolar disk surrounding stars and see just how stars first form. We'll also be able to look at a lot of things even in the outer region of our own solar system in the Edgeworth-Kuiper belt, maybe even out as far as the Oort cloud, where things are they're so cool that they are radiating or reflecting in the infrared rather than in visible light. So a whole lot of things that the James Webb can study that we can't study at all from the Earth because the infrared radiation doesn't get through, but that even the Hubble Space Telescope wasn't able to study. There were other infrared satellites up there, nowhere near as powerful as the Webb. Some of them have reached the end of their life anyway. So there's so many things that this telescope will be able to do that no other telescope can do, that it's just going to be groundbreaking, assuming, of course, that everything actually works as planned. It's on its way almost at the Lagrangian point, the L2 point, where it's going to be stationed. That happens, I think, in about 4 or 5 days, 23rd of January. But all the instruments still have to be fully tested. And most importantly, the final collimation of all the 18 different segments of the main mirror have to be exactly collimated. And this is something to try and get your head around. The surface accuracy of all 18 of those mirrors working together has to be accurate to the diameter of a coronavirus. Nanometers, about 10 nanometers. I mean, it's mind-boggling, and this all has to be done remotely. Now, because there are 18 different mirrors and they all have to not only be individually adjusted, but then to work as one, that is going to take quite a while. We're not going to get nice pictures back just as soon as it gets to the L2 point. We have to be patient. There's no point in sending back very blurred, disappointing pictures, although they will send some pictures back just to make sure that the optics are working and the transmission system is working. But we'll not get really clear pictures probably until around April or May. But if everything works as it's supposed to, this is going to just totally revolutionize various areas of astronomy.